channel. So today we're going to be talking about something which I find really interesting: convolutional neural networks. Convolutional neural networks are really powerful algorithms, and they've been used in a variety of fields to solve a variety of problems. So the basic thing with convolutional neural network is you can work with a huge amount of data, really complex data, and then you get really high accuracy in your results. Convolutional neural networks have been used to detect abnormalities on chest x-rays, from pneumonia to tuberculosis, and they've been also used to detect breast cancer lesions in mammograms. And in my thesis, I myself am using CNNs in my thesis, and I'm working on a medical problem. In this series, we're going to be talking about, we'll be starting with the basics of convolutional neural networks, which are perceptrons. So perceptron were proposed by Rosenblatt, and they form the core idea of any neural network. And then we'll talk about the basic building blocks of any neural network, which are sigmoid neurons. And then we'll move on to artificial neural network. We're going to be talking about the different CNN architectures that have performed quite well on the ImageNet challenge, your ResNet, AlexNet, InceptionNet, and GoogleNet. We'll start with small problems and then we'll move on to bigger ones. I'll also be showing you snippets of my theses, and we'll be coding in Python, and we'll be using Jupyter notebooks wherever we can. But then for more complex problems or problems with huge data sets, we'll need to use some cloud services like Nimblebox. So I hope you guys enjoy this series. It's said that when you teach, you actually learn. So the whole idea of making this series for me was to learn from you guys. So it's a bilateral process. So let's get started.
Hey guys, so we'll start by talking about a perceptron. Now, what is a perceptron? It sounds like something from a sci-fi movie, but it's actually a very simple concept. It was proposed by Rosenblatt in the year 1958. Now, who the hell is Rosenblatt, right? Rosenblatt was a very acclaimed psychologist. He did his PhD from Cornell way back in the 1948 or something, and then he got into cognitive research, and he basically laid the foundation for artificial intelligence as it is today. So what is a perceptron? Perceptron is nothing but this function. It's basically a linear classifier. So you have an input X and an output Y. And what basically a perceptron does is, if your input is greater than 0, your output is 1. Or if your input is greater than or equal to 0, your output will be 0. So basically, if you have a non-negative, non-zero input, your output will be, your perceptron will fire. And if your input is a negative number, the perceptron will not fire. That's the whole idea of a basic perceptron. It's something that you can use to, make decisions in its simplest form. It can also be likened to a step function. So if your input is X, then your output, if your input X is 0, your output is also 0. If your input X is greater than 0, then your output is also greater than 0. That's basically what a perceptron is. Now, moving on to something that concretizes our idea of a perceptron. Now, growing up, we've all watched Friends, and we all love Rachel and Ross and everybody else. So I'm going to give you an example in which we can use perceptrons for decision making. I hope you guys remember the list that Ross made when he was with Julie. He made a list where he had Rachel on one side and Julie on the other side, and they were using Chandler's new laptop to do this. And he had a few pros and cons for both women. So for Rachel, he said that Rachel is just a waitress and Julie was an archaeologist. and Rachel had chubby ankles, but Julie wasn't Rachel, so something like that. So what he was basically doing is he was weighing his inputs, if you so as to say. So what we'll do with this is, suppose I'm Ross and I'm trying to decide if I want to date Rachel. So as Ross, I decided to use perceptrons to make the decision for me to choose Rachel or Julie or both. Okay, so for the perceptron, Ross first has to choose the inputs. So his inputs are career. Okay, sorry, I don't know what this is. Okay. Yeah, so career is one of his inputs, then looks, okay, and then maybe affection, okay, how affectionate this girl is. Now for the career, Ross has to decide which of the inputs is the most important for him. So maybe he's a vapid person. Please don't kill me for this, but maybe let's suppose that Ross is a vapid person and he decides to give the looks a 5. So that's the most important, and maybe the career is next, and then affection comes in, and then he decides to give it a 3. So these are called weights for the inputs. These weights basically decide how important or how vital this input is for you, right? So if someone has a really great career, they will get more points, but if they lack affection, it's kind of the weights, since the weights are less, it's kind of a little bit, it's not as, it doesn't carry as much weight as looks. So now let's come to the perceptron. So I'm going to clear this off the screen. Let's just remember the inputs with career has a 4, looks has a 5, and affection has a 3. So these are my weighted inputs. Now let's build the perceptron for Rachel. Okay, Rachel. So these are the 3 inputs that I have. This is career, looks, and affection. Now I have to decide. For career, does Rachel get a 0 or 1? Since Rachel is a waitress, I think her input will be 0. And looks, she's top notch in the looks department, so let's give it a 1. And affection, let's give it a 1. Okay, so now what is the total input to the perceptron? So my total input after weighing all of the inputs will be 4 into 0 plus 5 into 1 plus 3 into 1. And I'm using this dot as a multiplier, okay, so because we don't have much space on the screen. This is going to be 0 plus 5 plus 3. So this is an 8, right? Now, I forgot about something, I'm sorry. So first of all, Ross needs to set a threshold for this perceptron, right? Because what a threshold decides is if the input is more than a threshold, then only he's going to have the perceptron fire, or the output of the perceptron will be a 1, or the yes, or the output of the perceptron will be a yes. So in this case, Ross decides that after a lot of thinking, he decides that for him to be able to date someone, the input should be greater than 10. Okay, so only if the input is greater than 10, then the perceptron is going to fire and he's going to go on a date with a girl. Now Rachel gets a score, the input for Rachel is 8, and since 8 is less than 10, the output is 0 and the perceptron does not fire, and he decides not to go on a date with Rachel. There you go, writers. He does not go on a date with Rachel. Now all of the Friends fans are going to kill me, but I don't care. Okay, so now next for Julie. We have the same 3 inputs for Julie. And we have the output for Julie as Y, we have the career, the looks, and the affection. Career, yes, right. Julie has a great career, so we'll give her a 1 here. Looks wise, I didn't really like Julie that much, but then Ross finds her attractive, so let's give her a 1. And she's very affectionate because she wanted to move in and stuff, and I think she really liked Ross. So now let's see what the input for Julie comes out to be. So we have a 4 into 1 plus a 5 into 1 plus a 3 into 1, which is equal to 9 plus 3, that is equal to a 12. Okay, so now you can see that 12 is greater than 10, which is our threshold. So we decide, so the perceptron is going to fire, and the output of the decision system will be a yes. So that means that yes, Ross is going to go on a date with Julie, and he's going to be much happier with Julie because they both have a lot in common. Well, that's what I think. I know that doesn't make any sense, but I'm not a writer, so I can think whatever I want to without being held accountable for anything. Okay, so that's basically the whole gist of using perceptrons for decision making. Really simple, very intuitive.
So that was it for perceptrons. In the next video, we'll be looking at a more formal definition of perceptrons, and we'll see how we can use multiple perceptrons to classify a point in a 2D space. So what do you guys think about perceptrons? What else can perceptrons be used for? Please tell me in the comments below. Also tell me if there are any corrections for me. I really appreciate any sort of feedback from you guys. Please like and subscribe to my channel, and I'll see you in the next video. Ciao!